Hi, we're going to continue with section 7.5, solving oblique triangles with law of sines. Oblique triangles. In this section, we learn to solve a triangle that has no right angle, called an oblique triangle. An oblique triangle is either an obtuse triangle with an angle greater than 90 degrees, or an acute triangle, all three angles are less than 90 degrees. It is important to note that an oblique triangle has no hypotenuse, so we cannot use Pythagorean theorem, nor can we use SOHCAHTOA to find trig relationships between the sides. Instead, we must develop other techniques for solving the oblique triangles. In particular, we will develop a new technique, the law of sines, and the law of cosines. First, though, let's look at other types of information we might be given. So, when working with law of sines in this section 7.5, we're going to be mainly working with two cases. First, we have angle, side angle. We're given an angle, a side, and an angle. We also will work with angle, angle, side, working with an angle, and a side. For law of cosines, we're going to have a bit more of sides. So you can work with side, angle, side, or side, side, side. And that's the next section, 7.6. You can also have situation 7.7 section of the ambiguous case, which is side-side angle. When presented with side-side angle or angle side-side, it is possible to get one triangle, two triangles, or no triangle at all. This is dependent of whether we're getting the angle we're working for is actually the angle within the triangle, or angle with it outside the triangle, or the triangle itself. So it's very fun to do, but you have to be very careful and we have to set up different cases for this. So that's section 7.7. You can go over it on your own. This is not a section we'll cover in this course because we're running tight on time. All right, let's move forward. Here, we're going to develop the law of sines. Now, I won't go through this proof with you guys, but you can read it on your own. So we're going to take the law of sines as given. These are your law of sines. They're pretty easy to develop or memorize. We are creating these fractions with the angle and its corresponding side using sine. So we're saying that sine of angle A over side A is equal to sine of angle B over side B, and sine of angle C over sine C are equal, and we can use these two fractions any way we like. We can set them up so that I'm working with sine of A and sine of B. I can set them up so I have sine of B and sine of C, or I can have sine of A with sine of C. We can use equality to create to work with any two proportions any way we like. Also, because we have an equal sign, we can also consider the reciprocal. So for this ratio, we can also work with side A over the angle, side B over the angle B, and side C over angle C, however you see best fit. How do you know when it's best fit? Which proportion to work with? We'll talk about this very soon, but it depends on what your unknown is. So this is your law of sines. This is our entire section, is using and developing, developing is what we're jumping over, using these law of sines to solve a triangle. Your strategy for using law of sines for angle side angle or angle angle side. We can use a law of sines when we know an angle measure and its opposite side measure. So you're given a whole proportion. So if you know angle A and side A, that's law of sines. If you're given angle B and side B, or angle C and side C, that's a law of sines case. From there, you must identify which side or angle measure is unknown. Is the unknown value and make the opposing value either a side or an angle measure is known. So here's how we can set up our equations. It's not absolutely crucial, but it makes it easier. It is good practice to put the unknown value you seek, side or angle, in the first numerator. So if I don't know the angle, make sure you start with sine above on the top left. If I don't know the side, make sure you write the side on the top left. This is so that I can set up and multiply my denominator, so your known side to both sides. And that makes 0, so they cancel off. And now we're left with this to punch into our calculator. That sets it up so there's a lot less algebra that might confuse you along the way. Let's move to example 1. Given angle A is 43 degrees and angle B is 85 degrees and side A is 8.1 centimeters, solve the triangle. Alright, so here we have a triangle listed. It doesn't matter what we label angle A, B, and C as long as we're consistent with the labeling. So here we have a triangle and we're told that we're given angle A is 43, angle B is 85, and A is equal to 8.1. Our instructions state to solve the triangle, meaning I need to find out what angle C is. I need to find the side of measure B. I need to find the side of, that's horrible, the side C. We don't know what that is. Why am I trying it backwards? We don't know what that is. And that's what we're going to do for this section. All right. From your answers, 1, measurement of angle C can be easily found from the other two angles, right? We know the sum of all 3 angles in a triangle is 180 degrees, so we just subtract the other 2 angles. So 180 minus 43 and minus 85, you get 52. All right, 2. Now we have to find those unknown sides. We have a pair of unknown values that are opposite of each other. So we have side A and angle A. We will use these values in the law of sine proportion we establish. The unknown value is side B. Let's use our reciprocal law of sines and place B on the upper left side numerator. Here is a setup. So like we said, it's helpful if we put the unknown on the top left. So we're trying to find B. So write B over sine B is equal to A over sine A. Now to get B by itself, we multiply both sides by sine of 85. Sine of 85. Those are gone, they make 1. So now we're left with this to punch into our calculator. 8.1 times sine of 85 divided by sine of 43. You should get something that's about 11.83. We round to the nearest tenth, so our answer should be 11.8. Now, a quick note, if your calculator sets you up with the parenthesis, make sure you close it. That was a mistake that or a troubleshooting error that we've seen. Now let's find C. We cannot use Pythagorean theorem to find C because it's not a right triangle. Instead, we will use the law of sines again. Note that we have a value of B. We could match up the C proportion with the B proportion. However, B is only an approximate value. It is better for the sake of accuracy for us to use the proportion for A again. Alright, so we're going to use our given again because we don't want to use something that we found that's rounded. I'll create a rounding error. Okay, so we're trying to find side C. Let's set it up. So C over sine of 52, which is angle C, is equal to 8.1 over sine of 43. We multiply both sides by sine of 52. And we do this to get C by itself. All right, now we're left to punch this into your calculator, and your answer is 9.3. Now, if you don't get the answer right, make sure you are in degrees. We're working with degrees, so make sure you're not in radians. All right, in class example 2. In triangle ABC, C is 90, A is 30, and side A is 6. A, solve a triangle using the relationship of 36 and 90 triangle. And B, show that the law of sines applies to this triangle. Okay, so let's solve it twice. So let's label our triangle. We have C is 90 degrees. This looks like 90, so that's going to be my C. A, B, C. We have C is 90, A is 30, and side A is 6. Okay, do you remember your 36 and 90 proportions? The hypotenuse in terms to your 30-degree side is 2 times A, so that'd be 2 times 6, 12. And the side of the 60 degrees is your side of 30 degrees, which is A, times square root of 3. So this would be 6 square root of 3. All right, so we solved this triangle. Let's go ahead and solve it again using law of sines. So let's draw our triangle again. We're told that A is 30, side A is 6. All right, we can find that angle B is 60. Let's go ahead and find C. All right, to find side C, we have C is equal to sine of C, sine of 90, is equal to, we have A's, right? We have angle A and side A. So we have side A is 6, and angle A is sine of 30. Okay, let's go ahead and solve C. Multiply both sides by sine of 90. So we're left with C is equal to 6 times sine of 90 over sine of 30. So punches in your calculator, and what do you get for C? Did you get 12? Yeah, right. So we can find side C, and I'll leave it to you to find and prove that side B truly is 6 square root of 3. Now 6 square root of 3 is going to be given to you in decimal form. So you're going to get something that looks like 10.39, so 10.4. All right, we're gonna skip in class example 3. Go ahead and try in class example 4. Try it on your own, pause the video, and then when you're ready to continue, unpause it so we can work it out together. All right, I'm going to go ahead and work out in class example 4 with you. All right, given the measurement of angle A is 94, measurement of angle B is 29, and side A is 12, find side C and round to the nearest tenth. All right, let's label what we know. We know angle A is 94. Angle B is 29. And therefore measurement of side A is 12. Remember that the side belongs to the opposite angle. find side C. So here's angle C. So I want to find side C and round to the nearest tenth. Okay, so notice that we have angle A and side A. Because we have one completed angle inside A, or one completed angle inside given, then I can use law of sines. So I want side C, that's our unknown. Let's go ahead and write side C in our equation. So we want side C over sine of C is equal, we have A, so A over sine of A. If it's helpful, you can always write your equation first and then fill it out. All right, so our side C is our unknown. Sine of angle C is, well, we don't know that either, but we can figure that out, right? So we have 180 minus 94 minus 29. And we get 57. So that's side of angle 7, angle C is 57. Is equal to side A, lowercase a is 12, over angle A, sine of 94. All right, you want to get C by itself, so let's multiply both sides by sine of 57. Those divide to make 1. So now we're left with C is equal to 12 times sine of 57 over sine of 94. And now we just use our calculator to find our answer. All right, I'm going to punch it out. So I first do sine. So sine of 57 equals times 2 equals divided by sine of 94 equals 1.68. So C is equal to 1.681,437. It continues on. You can round and say that C is about 1.7, and we're using centimeters as our unit. All right. Go ahead and try. You try it one. All right. I'm going to go ahead and solve it. If you haven't done so, it's a good time to pause the video, give it a try on your own, and unpause it so you can see what the work was. All right, we're told that the measurement of angle A is 41 degrees. The measurement of angle C is 32, and the measurement of side B is 83. Find side A. All right, well, we need to have an angle and a side given to begin, right? I have side B, I need angle B. Can I find angle B? Yeah, we can, right? We know that a triangle, all sides add up to 180. So we can take 180 minus 41 and minus 32. And that gives us 107. So angle B is 107 degrees. All right, we're trying to find the unknown side of A. So what is A? We don't know. Let's figure that out. All right, so we want side A. So our formula would be A over sine of A is equal, we have angle B and side B, so we will use B and sine of B. All right, side A is our unknown. Sine of A is 41 degrees. Side B is 83 degrees. 83 inches, and sine B is 107. Sine of 107. We multiply both sides by sine of 41, so we get A is equal to 83 times sine of 41 over sine of 107. Let's punch that into our calculator. So I first like to punch sine of 41, get an answer, multiply it by 83, get an answer, and then divide it by sine of 107. So our answer is 56.9, and that's rounded. And our units of measurement in this question is inches. All right, let's go ahead and continue with our next example. Next is an example from section 7.3 involving three triangles within one diagram. In section 7.3, we were concerned with only right triangles, so the oblique triangle was ignored. In this section, because of the law of sines, it is to our advantage to use the oblique triangles and just one of the right triangles. So example 5. In the diagram at the right, measurement of angle BAC is 31 degrees, as we see measured here. Measurement of BDC is 65, as we see here. And the distance from A to D is 90 degrees. Find the distance from C to D, labeled X. Round each to the nearest whole number. All right, so our goal is to find X. Well, if I want to find X, I need to have one. If I want to use law of sines, I need to have one angle in one side. While I know the angle B, I can figure it out, but that's not enough because the x's are unknown. I know angle C, and I can find the side Y so that I can use C and side C as my known values. Procedure. Separate the figure into two triangles, triangle ADB and BCD. Angle ADB is 115 because it's supplementary to BDC 65. We can then find that angle ABD is 34 degrees. Use the law of sines in triangle 1 to find y, then use the value of y in triangle 2 to find x. Triangle 1, to find y. I have y is equal to sine of 30 equal to 90 over sine of 34, and we use this to find y. Once we have y, we can use law of sines on our other triangle. Or, because we have that 90 degrees, you can use SOHCAHTOA. Now in triangle 2 to find x, we have cosine of 65 over x over y. So we just do a bit of algebra and we have x. All right, important notes about calculators and the law of sines. In section 5.3, one of the identities we see is that sine of 180 minus a equals sine of a. This says that the sine of an angle is equal to the sine of its supplement. For example, sine of 150 equals sine of 30, which is by 1/2. In chapter 6, we solved an equation where sine of theta equals 1/2. We got two solutions. Theta can be 30 or 150. In chapter 4, we learned that restriction of interval between sine is between negative pi over 2 and pi over 2, or 90 degrees to 90 degrees. And our calculators respect that by using sine inverse Q returns and acute angle never obtuse, which is great when solving right triangles. For example, sine inverse of 1/2 equals 30, not 150. So you're never going to get the supplement, meaning if we have a triangle, and let's say we're being asked to work with this triangle, it's not going to give you a hard time and give you this angle, right? That's what it's trying to say. It's always gonna give you 30. It's not gonna give you the supplement of 150 or the other option that would make it true. So what does this all mean? When solving oblique triangles, it is possible that one of the angles is obtuse. However, the obtuse angle will never appear when using sine key. So if we think of an angle might be obtuse because it is opposite a longer side, we must also consider the supplement of the calculator's answer. So this is getting us ready for our next section, 7.6. But it's a way to get around working with the supplement. For example, if sine of theta is 7.66, our calculator approximately gives us 50 degrees for theta. However, the answer might also be a supplement, which is 130. This is the ambiguous case mentioned at the beginning of the section. So the one time we might see this is if we're working with law of sines for the case of side-side angle. When we're in that case, we run the possibility of working with another triangle or this triangle not existing at all. But again, we won't see that. We're not going to go over it. But if we wanted to, we'd just create cases. We would say, okay, what if there's one triangle? This is it. Can this other triangle happen? This would be it. However, we do run a possibility of working with the supplement in the next section, 7.6, for law of cosines. But there's a way to go around it. All right, that's it for this section. Your homework is all odd problems. All right, if you have any questions, you can post them on our discussion board. Save your questions for our next class meeting on Tuesday, or you can email me. I'll be happy to answer your questions. Thanks.